Hello everyone. Today we are going to be discussing about the CPU scheduling algorithm. In previous class already we have discussed purpose of CPU scheduling algorithm and types. So today's class we are going to be discussing about the round robin CPU scheduling algorithm. So in previous class already we have covered CPU scheduling algorithms are of two types, preemptive and non-preemptive. So now this round robin comes under the preemptive scheduling algorithm. That is, it is also similar to the FCFS with time quantum. Only the difference between the FCFS and round robin is time quantum. In FCFS we don't have any time quantum. According to the how many processes are ready in the ready queue, and depends upon the arrival time, the particular process is going to be getting the utilization of the CPU. So here this mostly used in time sharing and the multitasking. The operating systems which are going to be using time sharing basis or multitasking basis, mainly these type of operating systems are going to be using the round robin scheduling algorithm. So here comes what is time quantum, how this algorithm is going to be working based upon the time quantum. Here the basic definition of the time quantum. So here time quantum is nothing but the period of time for which a process is allowed to run uninterrupted in a primitive tasking in number of rounds. So each process is going to be utilizing the CPU for certain amount of time. That period of time will be decided by the operating system, and each and every process is going to be getting the chance to utilize only that period of amount of time. If the time of that process needs more, again in another round it is going to be getting the chance. So let's say an example. So here we have taken number of processes. Let's consider number of processes are 5 with their arrival time and with their burst time. We already know that arrival time is nothing but the time when each process enters into the ready queue, and the burst time is the period of time how much the process, a particular process needs to utilize the CPU is nothing but the burst time. So first of all, for the given input table, we have to draw the Gantt chart. So we all know that the Gantt chart will initially or by default starts with the 0 unit of time. So now we are going to be discussing about the round robin. Let's consider time quantum is equal to 3. It may varies to each and every problem. For example, we are considering the time quantum is 3. So here nothing but each process will get only 3 units of time to utilize the CPU. So here process 1 is going to be having the burst time of 8. So that is nothing but process 1 needs 8 units of time to utilize the CPU to accomplish its task. But operating system has assigned only 3. So for the first time, whenever the P1 get the chance of utilizing CPU, it will utilize only 3 units of time, and again it will get the chance to utilize the 3 remaining burst time. So here, even though it is a round robin, first we have to start with the unit time of 0. Check at the table at time of 0 which process is available in the ready queue. So let's take one ready queue for easy understanding. So consider this is the ready queue. So at the time of 0 arrival time, so P1 is there in the ready queue. So P1. So first we are going to be giving the chance of CPU utilization for the process 1, as we have the quantum time as 3, so that the P1 is having the burst time of 8, but the OS is allowing the P1 to utilize only up to 3 unit of time as according to the quantum time. So after P1 is utilizing 3, next we have to check whether any other processors are available in the ready queue at the time of 3. So we can see here, while P1 is utilizing the CPU, P2 P1 has arrived as its arrival time is 1. P3 has arrived into the ready queue as it has the arrival time of 1 and no other processors are available. So now P3 will get the chance to utilize the CPU, and again it is going to be getting the 3 units of time to utilize. So 3 plus 3 will become 6. So already here P1 utilized 3. So out of 8, 3 has been utilized. So the remaining will be here 5. So now the burst time of P1 will become 5. And P3 is going to be having the 7, and now it has utilized the 3. So the 7 burst time will become 4. So up to 6 P3 has been utilized CPU. Now we have to check any new processors are available in the ready queue. So at time 5 P2 has arrived, and at time 6 P4 has arrived. Both P3 and P4 now is having the same arrival. So now after 3, P1 is already there with the less arrival time, and P2 is also arrived in the queue, and P4 is also arrived in the queue, and P3 still having the burst time to utilize the CPU, so that we have to keep the P3 also in the ready queue. Whenever the CPU is relieved by this process, but still this process is having the burst time to be used, then again this process will be available in the ready queue. It will not be terminated. After complete utilization of the CPU only, the process will be terminated completely. Otherwise, after utilizing some amount of time of CPU, again it needs some more time. It will be come into the, or it will be available in the ready queue. So after P3, so now P1 is completed, now P3 is also completed. Again P1 should get the chance. So now again P1 will get the chance. Again quantum time is 3, so it is allowed to use 3 times. As this is the preemptive is nothing but interruption. So OS can forcibly interrupt the process from utilizing the CPU and can allocate to the other processes, depends upon its arrival time and the burst time. So this switching can be possible only the preemptive type of CPU scheduling algorithm. So after completion of again 3 more, now this 5 will become 2. So which is available next in the ready queue? Process 2 is available, so that process 2 will get chance, and process 2 is having only the 2 units of time, so that it is utilizing complete burst time. Why? Because the burst time of process 2 is less than the quantum time. If any process burst time is less than quantum time, complete utilization can be done. So P2 is completed its utilization of CPU within 2 units of time, and it releases the CPU. So now this P2 will be terminated completely. So next after P2, P4 is available. So let's check here. At the time of P1 completed, here 9, the time of CPU utilization becomes 9. So we can check in the table, P5 is also arrived. After P3, P5 is also arrived into the ready queue. Why? Because its arrival time is 8. At the time of 8 only in the ready queue, P5 is available. So here the P1 got the second chance to utilize the CPU, and after completion of the second chance also still burst time is remaining here. So again P1 will be available in the ready queue. P2 has completed its utilization, so P2 is terminated. So after P2, which is available in the ready queue, P4 is available, so that P4 will utilize the CPU, and P4 is having the 3, as the quantum time is also 3, so complete 3 it is going to be using. 11 plus 3 will become 14. So now P4 will also be completely terminated and it will not again available in the ready queue. So after P4, again the second chance for P3 has got, and P3 already utilized 3 units of time and remaining with 4 units of time. So after utilizing one more 3, it will become 1. So here the utilization will become 17. So after completion of P3 in the ready queue, P5 is available. So now you can check, still P3 is needed one more unit of time to utilize. So again P3 will be comes into the ready queue. So P5 is having the 5, so that it is going to be using 3 units of time and it will become 2, that it will become 20. So after utilization, again P5 will also come back into the ready queue. After P5, again P1 will get the chance, and P1 is having now only 2, so that it is going to be using and it will become 22. After P1, so now P1 completely completes its utilization, so now P1 will be terminated completely from the ready queue. After utilization of this last utilization, the P1 will terminates, it will not come back into the ready queue. Why? Because it has completed all its burst time. After P1, again P3 will get the chance. Now P3 is going to be having only the 1 unit of time to be utilized. So 22 plus 1 will become 23. So now P3 is also completed all its CPU time utilization. So P3 is also going to be terminated. And last P5 will get the chance. And at P5 it is also remaining with only 2. So 23 plus 2 will become 25, and P5 is also completed its utilization, so that P5 is also going to be terminated completely. So by this we have completed the drawing the Gantt chart. This is the way how we have to draw the Gantt chart using the round robin based upon the quantum time and considering the arrival time also. So from this Gantt chart, now we are going to be calculating what is the completion time of each process, turnaround time, waiting time and response time. So now first calculate with the completion time of each process. So here completion of each process should be considered as right side. We have to move from right towards the left